Hello. Oof. Hi. Today on this first installment of what is hopefully a new series on my channel, we're going to learn about time dilation and what it is and why it's so freaking cool. Alright, follow me here. Time dilation describes the concept that when an object experiences high gravity, it also experiences fast time. And conversely, if an object is in a low gravity location, it experiences time more slowly. Relative velocity, the difference between the speed and direction of two objects, also plays a role. The people flying on a plane over top of you are experiencing time ever so slightly slower than you are, and time for you is happening ever so slightly faster than for the people aboard the plane. Here's an example that's easier to understand. Suppose you and your friend go on an intergalactic cruise, and while you're on that cruise, your friend mysteriously loses your Heelys. Luckily for you, the ship is about to take a pit stop at a black hole, where your friend can easily, mysteriously get lost off the side of the ship into said black hole. Because of time dilation, you, in a low-gravity spaceship, get to watch your friend suffer slowly until you start feeling like you maybe overreacted a little bit. Your friend, however, experiences time exponentially faster as they fall into the black hole. They watch the cruise ship zip by, they watch stars nearby explode, until they pass the event horizon, or point of no return of said black hole, where the gravity is so strong that they become human spaghetti. Quick note, velocity doesn't play a very big role in this example, as the gravity is so strong. Now you may be thinking, this is kind of cool, I think I'm going to click off of this episode soon, because I'm not going to a black hole anytime soon, so why does this matter, and how do we even know this is real? Well, due to Einstein's theory of special relativity, we've known that gravity affects time since at least the 1920s. In 1971, in the famous Haffler-Keating experiment, physicist Joseph C. Haffler and astronaut Richard E. Keating flew 4 atomic clocks around the world. 2 went around the globe east twice, and 2 went west twice. There was a third set at the United States Naval Observatory. When they compared the clocks, the times were different for each set, just as they'd predicted. The difference was only a few hundred nanoseconds, but those nanoseconds add up over time. For instance, the Earth's core is about 3 years older than its crust due to time dilation, and Russian cosmonaut Sergei Krikalev has gained a whole 22.68 milliseconds of life due to being in a low-gravity, high-velocity environment for so long. Your GPS even has to include time dilation in its calculations because it's run via satellites that run on nanoseconds. In case you got bored and skipped to the end, I have a quick recap. Time dilates depending on your speed and direction, as well as how much gravitational force you're feeling. It doesn't really affect your daily life, but it can if you believe hard enough. Hopefully you learned something, hopefully you liked this video, and I can make this a series. Hopefully I come up with an actual outro sometime soon. But until then, see you Monday!